Point. The primary method used is a quantitative longitudinal cohort study, which is highly suitable for investigating long-term health outcomes like coronary heart disease. Evidence. The research tracked 77,500 participants over an 8-year follow-up period, linking baseline activity and genetic data to future hospitals admissions and death records. Evaluation. This method is suitable because CHD develops over time. A snapshot, cross-sectional, study would not be able to show the progression of the disease. By using a longitudinal design, researchers can establish a temporal link between exercise habits and health outcomes. However, as an observational study, it lacks the controlled environment of a clinical trial, meaning it cannot definitely prove causality, only a strong association. Link. This approach provides high reliability through the use of standardized medical records to track the issue over nearly a decade. Activity 1, paragraph 2. Point. The study utilized objective quantitative data collection via wrist-worn accelerometers to measure physical activity. Evidence. Participants wore a device for 1 week to measure specific levels of sitting, light activity, and moderate to vigorous physical activity. Evaluation. It eliminates recall bias, where people forget how much they sat, and social desirability bias, where people over-report exercise or lie. The weakness is that 1 week of monitoring may not represent a person's lifelong habits, potentially affecting the long-term validity if the participant's behavior changed after the device was removed. Link. Using device-measured data increases internal validity of the findings regarding the 9% risk reduction. 1, paragraph 3. Point. The researchers integrated biochemical genetic data to categorize participants by risk level. Evidence. DNA samples from the UK Biobank were used to calculate a genetic risk score for CHD for each of the 77,500 individuals. Evaluation. This is a highly suitable method for addressing the specific issue of the article, whether exercise helps those with an inherited risk. It allows for stratification, enabling researchers to compare the high-risk group against the low-risk group. This adds a layer of scientific depth that traditional lifestyle studies often lack. Link. This precise measurement increases the validity of the conclusion that those with high genetic risk benefit the most from MVPA. Activity 1, paragraph 4. Point. The study used a large-scale, purposive sample from the UK Biobank, which impacts the external validity, generalizability of the result. Evidence. The sample consisted of 77,500 white British participants with an average age of 56. Evaluation. The large sample size provides high statistical power, making the 9% risk reduction finding very reliable. However, the validity of applying these results to the wider UK population is limited. The sample is ethnically humongous white British, and the subject to volunteer as biobank participants are typically wealthier and healthier than the average citizen. Link. While the methods are robust, the lack of diversity means that the findings may not be fully generalizable to other ethnic groups or younger populations. Conclusion of Activity 1. Overall, the research methods are highly suitable. The combinations of objective device data and hard clinical outcomes minimize human error and bias, resulting in high reliability, while the observational nature prevents a cause-and-effect conclusion. The scale and the use of genetic stratification provide a thorough level of evidence for a public health policy.